Now let's consider the case of infinite solutions. Before I do this, I'll define a pivot column. A pivot column is any column which contains the leading entry in the row echelon form of the matrix, and the pivot is another name for a leading entry. So if I have a matrix that looks like this, so this one's in reduced row echelon form. My pivot columns would be the first and the second. So this will be helpful in solving these infinite solutions. So let's consider an example. If I put this into a matrix, I get 1, 6, 4, minus 4, minus 6, 2, 3, minus 7, minus 13, 9, 3, minus 15. I already have a 1 in the first row, first column, so I will work on getting the zeros beneath it. The first one's a 6, so I'll do negative 6 times the first row plus the second row. Negative 6 plus 6 is 0. This is 24 minus 6 is 18. Negative 18 minus 7 is negative 25. Negative 54 plus 3 would be negative 51. Negative 4, row 1, plus row 3 gives us the second 0. This is 4, negative 4 plus 4 is 0. 16 plus 2 is 18. Negative 12 minus 13 is negative 25. Negative 36 minus 15, negative 51. So I'm going to skip getting the 1 in the second row, second column, and go ahead and subtract the first and third, or the second and third rows. So negative row 2 plus row 3. And this gives 0, 0, and 0 all the way across. So we can already see something's a little strange with the row of zeros. It doesn't fit the situation of no solution, but it does look like that similar idea. I'll now do the 1 over 18 times row 2. This gives a 1 minus 25 over 18 and minus 51 over 18. And finally, we should work on moving the negative 4 to a 0. In order to put this matrix in reduced row echelon form, which is what we want. So it's currently a negative 4, so we will add 4. 4 times row 2 plus row 1. This would be 0 plus 1 is 1. Negative 4 plus 4 is 0. Negative 25 over 18 times 4 plus 3 gives minus 23 over 9. Negative 51 times 4 plus 9 divided by 18 gives minus 21 over 9. You'll notice this can be reduced, but I'm not really concerned about that at this point. So let's try to move this to equations. x1 plus 0x2 minus 23 over 9 x3 is equal to minus 21 over 9, which is also 7 over 3. x2 minus 25 over 18 x3 is equal to minus 17 over 9. So this indicates infinitely many solutions, and in fact I have described the solutions right here with these equations. So everything that satisfies these two equations will be a solution to this system. So the variables that correspond to pivot positions or pivot columns are known as basic variables, and the others are free variables. So in my last example, x1 and x2 are basic variables, while x3 is the free variable. When we write solutions to general systems, we usually solve for the basic variables. And then the last variable, our free variable, can take on any value. So if you pick x3 to be a number, we can now determine what x1 and x2 must be in order to have a solution. So it is important to note that in order to have infinitely many solutions, there will not be a pivot in every single column. The row of zeros that we saw in the last example is not a requirement for infinitely many solutions. So here's an example to show this. 2, 4, minus 2, 8, and 3, minus 2, 7, 0. My first step is going to be 1/2 row 1 in order to get the 1 in the first row, first column. 1, 2, minus 1, 4. And the second equation will stay the same. I'll now get a 0 below that. So I have minus 3, row 1, plus row 2. Minus 3 plus 3 is 0. Minus 6 minus 2 is negative 8. 3 plus 7 is 10. And negative 12 plus 0 is negative 12. To get the 1 in the second row, second column, we will divide by negative 8 or multiply by negative 1 over 8, either way. This gives 0, 1, minus 5 over 4, and 3 over 2. Finally, we'll get a 0, do negative 2 times the second row, plus the third. So this is negative 2 plus 2 is 0. This will be 5 over 2 minus 1, which will be 3 over 2. And then negative 3 plus 4, which is 1. Our equations are x1 plus 3 over 2x3 equal to 1. And x2 minus 5 over 4 x3 equal to 3 over 2. Once we solve for our basic variables, we get that x1 is equal to minus 3 over 2 x3 plus 1. x2 is equal to 5 over 4 x3 plus 3 over 2.